Hello everyone, welcome to my channel. In this video, we will learn about different types of networks based on their topologies. So let's get started. First of all, I want to define what is meant by the term topology. So here it is. The network topology defines how various computers or electronic devices represented as nodes are connected to one another in the network. In simple words, network topology refers to the physical arrangement of devices in a network. Each device has a unique role in the network and is linked to other devices in such a way that data can be exchanged between them. There are many types of network topologies. Some of them are still used today, while others have gone out of style. As technology progresses and our demands for networking increase, some newer topologies have recently emerged and are being implemented. The major types of topologies include bus, star, ring, and mesh. Depending upon the type of topology, different protocols are used for communication among the nodes. Let's start with the most basic one, which is bus topology. In this topology, all the devices are connected to a single cable called a backbone or bus. This backbone cable acts as a shared communication medium for all the nodes attached to it. In a bus topology, the devices are not directly connected to each other. Instead, they are connected to a common transmission line. All the data in the network travels along this main cable. If any node wants to send data to another node, it will broadcast its signal to the entire network through the bus. Other nodes will receive this signal, and if the source and destination nodes are the same, then only the receiving node will pass the signal further. This continues until the data reaches the intended recipient. Here, the main cable can be a coaxial cable, a twisted pair cable, or an optical fiber. It doesn't really matter as long as all the cables are the same. Now, there can be multiple cables connecting to nodes, but at a time only one cable can be used for sending data. One advantage of a bus topology is that it is simple to set up since there is only one cable required for the connection. Another benefit is that it is inexpensive to build because of using just one cable and a small number of connectors. However, a drawback of this setup is that performance degrades when the number of nodes increases. Also, if the backbone cable breaks, then the whole network goes down. Next comes star topology. Here, each node has a direct connection to a central device, which can be a router, a hub, a switch, or even a computer. This central device connects all other nodes in the network. In this topology, every node is individually connected to the central device. So, if a node needs to send data to another node, it first sends the data to the central device, and then passes it on to the next device until the data reaches the intended recipient. Now, there can be multiple connections between a central device and another device. But one thing to note is that at a given time, only one connection is active. One advantage of a star topology is that if one connection fails, the rest of the network remains unaffected. Another advantage is that it's easier to detect faults in this topology as compared to others. In addition, you can expand the network easily by adding more nodes. You don't need to change anything in the existing network configuration. A disadvantage of this topology is that it requires more cables than a bus topology, which means increased cost. And if the central device fails, the whole network goes down. The next type of topology we will discuss is ring topology. In this topology, all the nodes are arranged in a circular shape. Each node is directly connected to two adjacent nodes, the one next to it and the one opposite to it. So, in a ring topology, there are no central devices like in a star topology. To understand how data travels in this topology, let's take an example. Suppose there are 6 nodes in a ring topology and the data needs to be sent from node 1 to node 4. If we trace the path along the ring, we see that the data can reach node 4 in only one way, which is through nodes 2 and 3. In this case, nodes 2 and 3 are called intermediate nodes. But if node 2 itself has data to send to some other node, then in that case too, it will get its chance. Once the data from node 1 reaches node 2 will pass the data to node 3 and then to node 4. After that, node 2 can send its own data to the other nodes. One advantage of this topology is that in most cases there is less collision as compared to a bus topology. In a bus topology, many nodes can try to gain access to the shared communication medium at the same time. But in a ring topology, only two nodes contend for access to the data stream at a time, so collisions are much less. Another advantage of this topology is that it's more resistant to noise. In a ring topology, data is sent in only one direction. But in a bus topology, data can be traveling in both directions at the same time. So, if there is some noise in the cable, it can affect the quality of the data in both directions. In a ring topology, though, the noise affects the data in only one direction, making it easier to detect and correct errors. A disadvantage of a ring topology is that if there is a break in the ring, then the whole network goes down. Finally, let's talk about mesh topology. In this topology, each node is connected to every other node in the network. There can be either a single connection between two nodes or multiple connections. When multiple connections exist between two nodes, the link is said to be redundant. In a mesh topology, if one link fails, the data can take alternative routes to reach the destination. This topology provides high speed and reliability. Data can be transmitted over multiple paths at the same time. This means if one path fails, the data can easily switch to another path to reach the destination. A mesh topology can be implemented using wired or wireless connections. But implementing a wireless mesh topology can be challenging. It requires more sophisticated equipment and is generally expensive. One advantage of this topology is that it's highly reliable. If one connection fails, there can be multiple other connections between the source and the destination. Another advantage is that it offers high bandwidth. Since multiple connections are available between the source and the destination, it can improve the speed of data transfer. A disadvantage of a mesh topology is that it's complex to design and implement. Additionally, it requires more cables than other topologies, which increases the cost. So these were the 4 types of topologies. We have covered their working and some advantages and disadvantages of each topology. Now, you might wonder how these topologies are used in real life. Well, in practice, these topologies are used as building blocks to form large and complex networks. For example, a star topology is commonly used in home networks. All the devices in the house are connected to a router, and the router is the central device in the network. A bus topology is often used in local area networks LANs. All the nodes in the LAN are connected to a single cable that acts as a backbone for the network. A ring topology is sometimes used in older networks, but it's less common nowadays. A mesh topology is often used in wireless sensor networks where reliability and bandwidth are important. It's also used in some industrial applications where a high level of redundancy is required. So this was all about the different types of networks. If you like this video, press the like button and share it with your friends. Also, if you have any queries, leave them in the comments section below. And if you haven't subscribed yet, please do so. Thanks for watching. See you soon.